Today we're working on factoring by grouping. So if you want to label your notes for today, it's called factor by grouping. I love teaching factoring because it's easy. I get frustrated by factoring because it's easy. And I think if you'll pay really close attention and zone in on the process, you'll find it easy too. But if you're not paying real close attention, just a minor detail will cause you some grief. So zone in on what we're doing here. First of all, when we're factoring, and I put factor by factoring. Let's try grouping. There we go. That's what I get when I talk and write. So the first step when we are factoring will always be to check or find the GCF. That's why we've spent so much time talking about GCF. Now, most of the time, the GCF may well be just one. If it is, it doesn't affect us much, really. And in factor by grouping, we'll always do when it's really easy to know to use it when you are factoring four terms. All right, so for example, if I asked you this example number one, if I asked you to factor 3x to the third minus 12x squared plus 2x minus 8. Immediately, I think this is a great candidate for factor by grouping because I have 1, 2, 3, 4 terms. The factoring we'll look at tomorrow will primarily be 3 terms. But if I see something's got 4 terms, I pretty well know, okay, this we're going to use factor by grouping to do. Now, there's going to be some steps here. The first thing I want to do is check the GCF. Okay, so there's an x to the third power here, an x squared here, and this term, an x there. No variable there. So there's no variable greatest common factor. My numbers, my coefficients are 3, negative 12, 2, and 8. Well, when I've got a 2 beside a 3, there's nothing that's going to divide those except 1. So my greatest common factor here is 1. So there's no greatest common factor to take out. Now, step number 1. We're going to split this 4 into 2 binomials. I'll show you what I mean by that in just a second. Then we're going to factor the GCF of each binomial. And lastly, we'll write our answer from that. Okay, so I've given you just 1, 2, 3 steps to do factor by grouping. Now let's talk about really what do those steps actually mean. Well, first of all, my first step after I find the GCF is to split it into 2 binomials. And here's what I mean by that. I'm just going to break it into 2 halves, just like that. So I'm going to go down here and rewrite that with parentheses. 3x to the third minus 12x squared. Okay, and then plus 2x minus 8. Now, all I want to do is to look at just the binomial that I've created here by itself, one at a time. Let me show you what I mean by that. All I'm going to do is now look at the first binomial that I created. And in it, I see that there is a greatest common factor of 3, because 3 will divide 3, and 3 will also divide 12. So what I want to do is get the greatest common factor out of this binomial. It's pretty simple. There's only 2. Now I've got an x squared, I'm an x to the third. I've already learned that I want to factor out to the lowest exponent of the 2. And then I'll rewrite this. So 3x squared. So it's 3x to the third divided by 3x squared. Well, 3 divided by 3 is 1. Don't need to worry about that. X to the third divided by x squared, it's just x. Same thing here. 12x squared, of course, I'm going to keep the negative sign. 3 divided by 3. Excuse me, let me say that correctly. 12 divided by 3. 4. X squared divided by x squared is just 1. All right, so let's move on. Now I want to look at the second binomial. There I see that I can factor out a positive 2. And 2 divides by 2, 8 divides by 2 evenly, but there's no variable to factor out. So if I do that, 2x divided by 2 is just x. 8 divided by 2 is 4, so it'll be a negative 4. All right. So just look at those 2 parts individually. Now I come back to pull my factorization. Here's what I want you to see. The cool thing about it was when I took the greatest common factor out, what's left in the parentheses is the same thing. If that doesn't happen, you're stuck, and you've got to either move the polynomial around, but the goal is to get it so that there are, in the parentheses, identical binomials. So we've got that. That really moves us along. So here is my factorization. I'm going to take the 3x squared plus in the plus 2 portion, and I'm going to basically undistribute the x minus 4. Let me show you what that looks like. It's really easy. My answer is 3x squared plus 2 times the parentheses x minus 4. Just write that down once because I've undistributed it. And then it is factored. That's my factorization. That's all there is to it. Well, let's try a second example. And we'll move through this one just a little quicker so that we can factor. We're beginning to get an understanding here of it now. 2x to the third plus 12x squared plus x plus 6. And the first thing I want to check, this is a parentheses, by the way. I kind of added that prematurely. All righty, so if I try to figure out what is the GCF, okay, of this particular polynomial, two and two both will divide by 2, but this has a 1. This has coefficient of 1, so my GCF has to be 1, okay? Then I've got x to the third, x squared, x, and then no variable. So the GCF here is 1 of the entire polynomial. I don't have to worry about that at all. So I'm going to break it into 2 binomials. The GCF, and again, I'm just only going to look at one binomial at a time. I can factor out a 2 and an x squared. So I'll write down 2x squared. Now 2x to the third divided by 2x squared is just x. 2x squared divided by 2x squared is 1. Okay, so that factors out to be x plus 1. Look at the second half now. x plus 6. What did I do? I copied it down wrong. Okay. Let me do that. Okay. If I do that, if it's 12x squared, then 12x squared divided by 2x squared will be 6. Otherwise, what I had was not going to work, so I needed to correct that. All right, now let's look at the second half. All right, so it's plus x plus 6. There's nothing to factor out of x plus 6. Now, here's a little tricky part that you need to remember. Even if there's nothing multiplying against this parentheses, there is a 1 there, and I have to represent that. It just can't disappear. So when I go to factor it, it becomes 2x squared plus 1 times x plus 6. Let's look at a third example. And again, I can't emphasize enough how important it is that you write these down to factor them. You can't do this in your head. It's just not going to work. All righty, so this one is 3x to the third minus 4x squared minus 6x plus 8. First thing I want to determine is what's the GCF. All right, so I've got a 3, 4, 6, and 8. 3 won't divide into 4 evenly. 4 won't divide into 6. So my GCF here first, it looks like at least numerically it's 1. X to the third, x squared, x, no variable, so there's no variable portion of that either. All right, so let's break it down in a couple of binomials, okay? Look at 3x to the third minus 4x squared. Now, I can't factor out numerically anything, but I can factor out x squared. So I'll be left with 3x minus 4 because x to the third divided by x squared is just x. X squared divided by x squared is 1. So the greatest common factor is x squared factored, 3x minus 4. Now, this is a trick a little bit. Notice I've got a leading negative 6 here and an 8. I can factor out a 2 and I'll get negative 3 plus 4. But what I want to have is positive 3 minus 4. Typically, when this binomial starts out with a leading negative, I want to factor out not a positive 2, but rather a negative 2. Notice negative 6 divided by negative 2 is positive 3x. And a positive 8 divided by negative 2 is a negative 4. By doing that, the binomials are the same. So my factorization, x squared minus 2 times 3x minus 4. Well, I only want to look at 2 more examples and then give you some opportunity to practice. And really, it's incredibly important that you practice these in order to be able to understand them. So let's look at 2 more examples. Example 4. This one is, we want to factor, and again, it's because it has 4 terms, I know it's got to be a factor by grouping. So the first thing I want to do is look at this and say, is there a GCF here different than or greater than 1? So I've got 4, 8, 12, 24. Whoa. Now, if I'm pretty good with my multiplication facts, I see a bit of a pattern here. Just the smallest number is 4, and 4 will divide 8. 8 divided by 4 is 2. 12 is divisible by 4 because 12 divided by 4 is 3. And 24 is divisible by 4 because 24 divided by 4 is 6. So I do have in this problem a GCF. It's 4. And also, there is a variable of x in each term, which I can factor out to the lowest degree. I can factor out an x. So my first step here, I have to actually factor out that 4x. So let's pull the 4x out. Okay, so 4 divided by 4, 1. X to the fourth divided by x to the first will be x to the third. I'm just saying 4 minus 1. And I get x to the third. Negative 8 divided by 4. Well, that's going to be a negative 2. X to the third divided by x, x squared. 12x squared. Okay, so 12 divided by 4, 3. X squared divided by x, x. Last but not least, negative 24 divided by 4, negative 6. X divided by x, 1. Hope you're writing all this down, especially to refer back to. So I want to break this then into 2 binomials, so I'll do that just like that. I'm not going to pay a lot of attention to this 4x for now. We'll just kind of move it out in front. And I will look at each binomial individually and see what now I can factor out there. So again, I'll write 4x over here, kind of just leave it. I'll use a bracket to isolate it. And I've got x squared will factor out of this first one. There's not any sort of a constant that will factor out. So it's x squared, and x to the third divided by x squared will just be x. And negative 2x squared divided by x squared is just minus 2. Okay? So I factored out that x squared from this binomial. Again, I'm just looking at one piece at a time. So let's look at the other piece. I can factor out a 3 from both 3x and negative 6. So I'll factor out a positive 3, and then I'll be left with x minus 2, just like that. All right, so let's wrap this up. Again, I'm going to bring this greatest common factor I found earlier down and keep it. It just can't disappear. And I've got, and my binomials now are identical, so I've got x squared plus 3 times x minus 2. One last example to look at. This is example 5. All right, again, we're factoring. And this is 10ab minus 15a times negative 14b plus 21. All right, so I'm sorry, I went ahead and put parentheses in there. My bad, I shouldn't have done that. But that's good, we'll just leave it. Checking the GCF, I've got the smallest constant I've got here is 10, and 10 will divide by 10, 5, and 2, and 1. Well, 15 will divide by 5, 14 won't. 15 won't divide by 10, so we'll have to go down 1. 10 will divide also by 2, but 15 won't divide by 2. So my GCF here has to be 1. And then there's A, B, and A, B. And so there's not the same variable in all four terms. So my GCF is 1. Don't have to worry about factoring anything out. I've already broke it down into two binomials for you because I kind of got ahead of myself. And then let's look at the first binomial. I can factor out a 5, because 10 and 15 are both divisible by 5, and an a. So I'll be left with 2b minus 3, because 10 divided by 5 is 2. A divided by a is 1. You have to bring the b down. 15 divided by 5, 3. A divided by a, 1. So there we go. Negative 14b plus 21. I've got a leading negative, so I'm going to have to factor out a negative. It looks like both 14 and 21 would divide by 7. No variable to factor out. So it becomes positive 2b minus 3. I can almost look back at this binomial as a guide, because remember, I want the two to be the same. So the factorization is going to be 5a minus 7 times 2b minus 3. And so now it's really not a complicated process to factor by grouping. And I know to factor by grouping when I've got a polynomial of 4 terms. I know to check for the GCF and then break it into a couple of binomials and then find the greatest common factor of those two sets of binomials. And I'm able to use a pretty simple process to factor by grouping.